But I know a lot of us don't have a lot of networking experience. How many would say that they're real comfortable with networks, with IT, data transmission? Pretty experienced. How many
Define really comfortable.
Why don't you define comfortable? Where are you at? Can you wear up a switch? Can you, I mean,
I don't know what I don't know.
you don't know what you don't, I love that.
So I guess I'm comfortable and dangerous.
Let me put it like this. How many in the room started their career as HVAC technicians or electricians or in one of the contracting fields? Okay, so that tells me what I need to know right there. Okay, so maybe you've been around it, you've been exposed to it, but you're not quite where you want to be as far as comfort level. And that's great because that's where I started HVAC tech and then a controls tech 25 years ago and was part of the whole IT revolution, but never really all the way into the revolution like Robert, so I had to learn along the way. So I think that as we were talking, Robert and I, and setting out the things we want to talk about for the prepping for the hands-on work, we wanted to at least touch on a little bit of concepts with networking. Now, obviously, in 2 hours, we can't go, we can't really get into the topic that much, but at least touch on some of the lingo and bring a little bit of clarity to you on the things that you're going to see later today and tomorrow. Specific to cabling, specific to making connectors, RJ45 connectors, specific to standards for communication and Ethernet, what's a switch, what makes a switch different from a router, what makes a router different from a gateway. If we can just get to that basic level of understanding, then I think it's going to help as you guys start running those cables and making the connectors and giving everything its own IP address later today. How many of you would know, let's say, what a subnet mask is? Are you comfortable with the definition for subnet mask? Okay, so a quarter of you. Okay, talking about stuff like that as well, okay? Make sense? Now we are a little bit behind, so I'm going to sail through some of these early slides that are very introductory, but if you need me to slow down, let me know and stop us. We'll try to address any questions along the way, but we are probably almost 2 hours behind now, and we want to get over to the lab. But this is important, okay?
Could you talk about that second bullet on that first slide?
Sure. Let's see.
Back one, right here.
Okay, so basic proficiency in networking skills is critical to BAS technician success, and topics covered in this section are introductory in nature, but really should be introduced early and often in your coursework to your students. And I know, Bill, that's one of the first things when you had your first cohort, you were running cables and making ends, but I'm sure the students loved that experience, right? So, absolutely. Okay. Basic definition of a network is simply anything where two computers are connected in some fashion or two nodes and they're exchanging information. You can create simple networks by connecting office computers to their NIC cards. I'm not sure all of you have heard about NIC cards, network interface cards, right? And then changing the settings in the computer's operating system. Just basic Windows has networking capability within it where you can do that. So why bother with networks to begin with? Well, networks are all about sharing resources. And if you're as old as me, you remember the old coaxial cable days with the BNC connectors and trying to make all that run on Windows 95 and before and all the fun that was. We've come a long way since then. But it was all about sharing resources back then. And I remember early in my career, that was so exciting. Oh my God, we can make two computers talk to one another and share basic, printer resources or files or whatever without having to put it on one of those big floppy drives and run it around the office. You remember those days too. So anyways, there are two types of computers that would be on a network. One would be a server and one would be a client. So a server is anything simply that's serving information to other computers and resources, providing those resources on a network environment. And that could just be two computers. It could be a whole network of computers. And then clients use those shared resources. One thing that you'll hear in our industry quite a bit is this dedicated server. What's a dedicated server? A dedicated server, you've got one in your classroom. Dedicated server is just all the time, what is it doing? It's just providing resources to a network or to other computers. And usually that computer, or it could be a web server or something like that, is just serving up stuff that can be used by others on the network. Okay. They can also be set up as peer-to-peer networks. You could connect all the computers in this room on a peer-to-peer basis. And Windows supports that. You don't have to have any kind of operating system, special operating system, to accomplish something like that. So in that case, you would all be peer-to-peer computers on a network. Probably the most common operating server software out there today is Windows Server 2016. And they come out with new versions of that every couple years. To update that, that would be for more of a dedicated server, serving a bunch of computers, in a network environment. Okay. What are the key components that you need for a network? Well, you need some kind of NIC card, unless you're running a wireless network, which a lot of you are on right now, the campus network on the wireless. But a lot of times you'll need some kind of network interface card with an RJ45 connector that plugs in, and then you get on the network. You need some kind of networking media, cabling. You need a network switch, a router, et cetera, et cetera. Sometimes you'll hear the term hub. There really aren't, you know where I'm going with that, there really aren't hubs anymore, but we still use the term loosely, a hub. A hub would be different than what a switch is. A hub is basically something that takes a signal in on the network and then just pushes out signals off all the ports. Wastes a lot of time, is not efficient. Switches is what we use today as the appropriate term. Everything has kind of got some smarts in it so that it routes those packets of information where they need to go and makes the network more efficient. Okay? So you need something like that, a switch, a router, et cetera, et cetera. And we'll talk more about that in a little bit. Some kind of network software like Windows Server 2016. You need a network administrator. You need a Robert, or somebody like Robert, who can manage the network, because in a campus network like this, you're going to have a lot of things to do, a lot of issues you have to take care of, a lot of permissions you have to set up. I'm sure this is a managed network, campus network. So in a smaller network, you might not have to do that. You might just have a plug-and-play switch and closed network like you have down at Miami Lakes, and just go with everything kind of plug and play. They don't need to have a managed situation. Network switches. Network switches connect everything together, all the nodes on a network, and it manages the flow of data efficiently by transmitting received data packets only to their intended recipients, like we just said. Each networked device is identified by its own specific network address. It's very important that all the host IDs, all your computers, if you were on a network here, would have to have your own host IDs, and they'd have to be all separate and independent. That's often accomplished by DHCP software, which we'll talk about later, server software that assigns those numbers. But if you were to do it in a static IP arrangement, you'd have to have a network administrator that gave you all separate network host IDs on the network. We talked about hubs already. Okay. They can be mounted in a number of different ways. The key point here is you can buy managed switches, or you can buy really unmanaged switches. In an environment like this, you'd have to buy some kind of managed switch, because you want to have some kind of control about where your packets are going, who's accessing the network, you know. Yeah, go ahead.
And I got a question that I think is kind of related, and I always have trouble trying to describe this. How ports are associated with all this idea of switches and data flow.
Yeah.
Because ports is, I guess, more of a software way of looking at
Yeah.
data management, isn't it?
Yeah.
I mean, and I'm even kind of confused about that. Like,
Maybe there'll be more clarity as we move forward a little bit,
okay.
because some of that we'll address. Do you have a quick answer for him, Robert? You'd like to share?
Quick answer.
Yeah.
We'll get there.
Yeah.
Bear with us. And just to be clear, you are talking about like port numbers, like for web.
What,
or
80 or
video
equipment,
things.
yeah.
Because there are also physical ports. Each thing that you plug into is also called.
Yeah, no, I'm talking about the ports as in,
Okay.
you know,
Not a quick answer, but we will get there.
27808, you know, whatever.
Okay. So a network router. What does a network router do? Well, network router connects two similar networks. Like a simple example would be at your home. How many have DSL service in your home? Okay. You're going to have a router in your home that connects all the devices around that network in your home to the internet service provider. That's going to be a router, okay? So think of a router in those terms. Large routers build up their own routing tables, and you'll hear that term in our industry as well. The most efficient way to route data packets to their intended targets. And as it's in service, it builds up these router tables, et cetera, et cetera. That's something that BAS technicians sometimes have to deal with, setting up router tables when they do installations. A network gateway, the term gateway, this is a little different than a router. There's a lot of people use those terms, you know, kind of interchangeably, thank you. But they're not the same thing. A gateway is really almost like a translator. It's going to translate between two dissimilar types of networks. Like think with a router, you might have a TCP/IP network on one side and a very similar TCP/IP protocol on another side, and then that router is going to route between the two because they're similar. Well, with gateway, it could be something very different on the two sides. Yes.
To go back to our residential comparison, for those of you who have cable or DSL at home, we call what we connect to their side of the network, we'll say, either the DSL provider or the cable provider, we connect what we call a modem, right? A cable modem or a DSL modem. Well, in reality, that's actually a gateway. So we've got that modem that we connect our wireless router to. So that's to kind of help understand that difference. We use them in a number of other ways in building automation, but we'll get to that.
Okay. And here's just a quick representation of what it might look like in your home or with a router connecting to an ISP, et cetera, et cetera. I know I'm going to go through this very fast because we want to get over to the lab. So stop me if there's anything that's not clear or that you don't want, you know, to ask about. So let's switch over to TCP/IP. We hear TCP/IP a lot. Who has a good definition of what TCP/IP is? What is TCP/IP? Or what is IP? Let's just start with IP. Anybody who's worked with BACnet is going to be familiar with BACnet IP. What is that really? What are we talking about there?
The way the information's packaged.
Yeah, it's a set of protocols. The protocols, think of that as a language, a specific language with rules of constructing that language and communicating that, like English or French or whatever. Think of a protocol that way. IP is Internet Protocol, okay? TCP is Transmission Control Protocol. And under those are a number of other protocols that build what they call a TCP/IP suite of protocols. Basically, it's rules and standards for communicating, okay? Network protocols are standards and policies which define communications over a network. They govern managed data network communications, and we said already it's a suite of protocols. But what is actually being transmitted across those networks? Ones and zeros. Ultimately, it's all ones and zeros. It's binary. And it's assembled in what's called packets. And these data packets can be very different depending on what kind of protocol that you're following. If we're following an Ethernet protocol, those are going to be very specific as to how they're constructed. So you have the data that you're transmitting, the payload, so to speak, and then you'll have a header, you have a destination, you'll have a time to live for the data packet if it doesn't get where it's going. You've probably all seen that when you've pinged and you get the TTL and it says 10 milliseconds or whatever it is. You have a whole number of things that would be included in that data packet as it's being sent. It's also limited as far as size. In Ethernet, it's 1,500 bytes or 1,500 bits, I think, or 1,500 bytes, one of the two. And this is something, if you're having problems, how many of you have used Wireshark or some kind of data capturing software?
Be very mindful about people who have a hub and a Wireshark installed on their computer. Because the hub is not like a switch. A switch switches from port to port. It knows which port is going to go and which port is going to leave. If you have a hub and you have a Wireshark, you can hardware sniff every packet that goes on all those lines. So you can see what protocol goes where, addressing and everything that goes. What actually software is used for those protocols. It's, but that's a very in-depth knowledge in matter.
We got a new teacher here, folks.
I'm sorry.
No.
I
No, it's
studied
good,
that
thank you.
10, 11 years ago, and things have changed drastically
Yeah,
since.
Changes so fast. I mean, it's changes so fast. Okay, so let's just keep going here. Back to what you said about what is it really? What makes all this up? It's basically zeros and ones. And this is something that should be, honestly, in all your curriculum. You should be covering binary. Not that your students are going to have to convert between binary and decimal or hexadecimal or anything like that. Although I think it's a good thing to go through that with them. But it's very important to understand and can lay the groundwork for logic as well. Logic instruction, gate instruction, ones and zeros are really just, true and false. And it lines up very well to introducing students to relays, to wiring, et cetera, to leading into decision making and, programming, et cetera, et cetera. But what is binary? Well, all of you are probably familiar with binary, right? In our decimal number system, we have 0 through 9 that represent the numbers that we typically use, our counting numbers. In the binary system, because of computers having switches that are either open or closed, our transistors are either open or not conducting or conducting, we're set up on zeros and ones. And that's how everything is constructed in a computer, basically. And that's why when you're looking for a computer, let's say, and you want a megabyte of data storage on that computer, it's not exactly 1 million bytes of storage. It's a number that's a 2 to a certain exponent. Like, if you had a kilobyte of storage, it's not going to be 1,000 bytes. It's going to be 1,024 bytes because it's, again, an exponential number of 2. So anyways, I don't want to get into it too much, but you've all seen this, right? Converting between binary and decimal, et cetera, et cetera. In the binary number system, every place in that system has its own value. So starting from right to left, the first digit is going to be 2 to the 0 because there are only two possible states in that position. Whereas in the decimal number system, in that position, we all remember back to our counting, right? There's 10 possible numbers that could be in that position. So basically, if you're not familiar with this, I would suggest that you introduce this to your students so that they can get at least some basic understanding of binary and its importance in our field. Okay, so as I said, it lines up very well with the 4 basic logical operations, okay, and they're shown here. The AND, which compares 2 binary values. If both are 1, then you get an output of true. The OR, which is if either one of those is true, you get an output of true or 1. The XOR, exclusive OR, which means if you have either one exclusively that's true, then you get an output of 1. But if both are true, you get an output of false, of 0, okay? And then the NOT, which deals with a single bit that basically just flips the state of that. And then there are a number of others that are derived from that, et cetera, et cetera. Here are some of the symbols and the way we represent some of those logic gates. Again, I know with our students, we would go through, as basic introductory wiring, we'd go through every one of these and make them wire it up on relays, on standard relays, and there were a number of benefits to that. Anyways, just an aside, okay. And so what gate would this be? Just taking a quick look at it. Anybody?
OR gate.
Hmm?
It's an OR gate.
Yeah, you got it. Yeah, exactly. Yeah, in a ladder diagram form. And you start seeing the connection between wiring up relays and how the gates operate, et cetera, et cetera. Okay, any questions on any of that? Very basic stuff, and this is all available as well to you when you go back to your institution if you want to look at it. So, okay, so let's talk about now, we've talked about binary, so that sets us up well to talk about IP addresses, okay? In Internet Protocol, an address number, you have to have a unique, as we said, a unique node for every IP address on that network, okay? IP addresses in the IPv4, which is Internet Protocol version 4, are 32-bit numbers. So you have 32 places of those 0 and 1s that assign both the network ID, which is basically the network on which all the hosts or your computers are going to rest, and then the host, okay? So every one of those has to have an independent unique number, which means that theoretically there are over, well, 4 billion independent addresses on the network. There really aren't that many because of something we'll talk about in just a minute, which is the classes of networks. But theoretically, we could have that many. And that's more than what we'll ever need, right? That's what they thought. Unfortunately, due to the way that the addresses have been allocated by IANA, which is the International Association of Numbering for the networking field, they're running out. They're fast running out, okay? And we have some techniques which we'll talk about which can extend those numbers, but it's still, we're going to run out at some point. So IPv6, Internet Protocol version 6, is starting to take hold, which gives us way more numbers than we'll ever need. Actually, it does. This time it does. 2 to the 128th power. I think somebody related to me one time, if independent IP addresses were assigned from the start of the universe 14 billion years ago, every millisecond, we still would have only given out 1% of the available IP addresses under IPv6. So probably that will be enough, maybe, but we'll wait and see.
That's 3.4 to 38 decimal places.
Yeah, I don't even know how to pronounce that number. It's a big number.
A bazillion.
Sounds good to me. Let's go with that, but gazillion, whatever. So the primary purpose of IP is to enable communications between networks. So therefore, the 32-bit IP breaks up into 2 parts. One for the network ID or network address, okay? And one for the hosted ID or the host address. Okay. Most of the issues that people have in working with IP are figuring out what part is the network address and what part is the host address. Okay. When it was originally founded, they came up with a classification system. And one thing about 32-bit numbers also is they're very hard to visualize. It's hard to look at it, ones and zeros in 32 places. So one thing that is going to look very familiar, you've all seen this, decimal dotted notation. We'll be dealing with that later today when we start addressing our host, our network and host IDs for the EasyIO controllers. But that's the way that we see it, and that's the way that we deal with it, decimal, dotted decimal notation. Okay, but it's even easier for us than that. If you put in that on your web browser, yeah, you would go to that particular site, but we have what's called also domain name server functions that give us names instead of numbers. So if you want to go to Google, you put in Google, you don't put in, 192.168. whatever, but you could put that in and go there because that's how we get to the sites where we want to go. Ultimately, ones and zeros. Okay, so the early designers understood that they have to strike that balance between networks that had a huge number of hosts or computers or devices, nodes, and those that had a very small number, like we'd be considered a very small number of hosts or IDs, host IDs, et cetera. So the approach they came up with was to define classes of networks. And there are 5 different classes. There are A, B, C, D, and E. And we're going to talk just about A through C because D and E are reserved. D is multicast, and I don't remember what E is, what the class is. Experimental, okay. Not anything we're going to be dealing with, but we will have to have some kind of working knowledge of class A, B, and C. Okay. So talking about first the class, I don't know if we want to get into all this. Basically, class A is going to be your very large networks. Okay, think of it like that. You're only 126, AT&T, IBM, Department of Defense, U.S. Postal Service, big networks with up to 16 million host IDs, available on that on their networks. The Class B networks would have up to 65,000 hosts or computers or nodes within their network. And then Class C networks, which we're going to be dealing with, would have up to 254. But you have over 2 million independent network ID addresses. Okay, so that's how they kind of broke it up when they set up, when IANA and the founders set up the the IPv4. Okay. And here's some well-known Class A networks, as Robert was talking about. GE, Network 3, IBM, Network number 9. You know, you can find all this at iana.org. They list out all these numbers for you. You can take a look at that if you're interested. So let's look at Class B real quick. Class B, they thought would be a good mix of network IDs and host IDs, but it turns out that there are actually very few organizations that even need, 65,000 host IDs. So what you end up with is a lot of wasted IP addresses, basically. Okay. And Class C networks, in this case, the first 3 octets, or the first 3 in the dotted decimal notation, you have those 4 parts of that. The first 3 of those for the network ID in a Class C network, and then the last octet, which gives you up to 254 independent host IDs for the computers or the nodes that you have. Now, why is it 254? Because 2 to the 8th power adds up to 256. So what happened to those other 2? Go ahead. You broadcast? Yeah, you start. Yeah,
Yeah, I mean, you've got those 2 reserved.
exactly. The broadcast, which one of that? Do you remember?
Isn't it the bigger number?
Yeah.
Yeah, 254.
Yeah, and then the 0.
255.
Okay.
Mhm.
Well, it's
Yeah.
a bigger number.
That's why it's not 256. Yeah. Okay, good answer. Okay. Okay, so since we're running out, and we've known for a long time that we're running out of those host ID, or really the IP numbers that we need, a technique which allows administrators to use those 32-bit numbers more efficiently is subnetting. Okay, how many of you have heard of subnetting? Probably most of you have heard of subnetting. Okay. It's unbound by Class A through C restrictions. Provides a flexible way to assign a portion of an IP address which indicates the network ID versus the address ID, or host ID, I'm sorry, the network ID from the host ID. So basically the network that you're on versus the individual computers, the host ID computer numbers themselves. So subnetting lets you select the number of bits to use for that network ID. There's a few compelling reasons to use subnetting. One, it allocates limited IP addresses more efficiently. Okay. Even if a single company had thousands of network devices using the same network ID for all of them would be impossible because of what you just brought up. Because by TCP/IP protocol, if you're on the same network ID, you have to be on the same physical network to broadcast. Okay. So this gets us around that limitation. Subnetting gets us around that limitation. A subnet is a network which exists under another Class A, B, or C network, just like it sounds. It's a subnet. It's not a physical computer.
I related to zip codes when I'm explaining it.
Okay. Yeah, it's a good way. It's a good analogy. Yeah. They're created through taking one of the host ID bits and extending that to the network ID. To work, the router must be instructed as to which portion of the host ID is to be used for the subnet's network ID. And this is what it looks like. Whenever you see a number like this, you know it's a subnet mask, because if you're in a Class A, B, or C network, it's very prescriptive. A Class A network is going to start with a 0. Okay, a Class B network is going to start with a 1, 0, I believe. And a Class, I think it's 1, 0, and a Class C is going to start with a 1, 1, 0. Yeah, that's right. So you know that just looking at the number itself, you're going to know immediately that you're on a Class A, B, or C network. And you're going to know in this case that immediately this is a subnet mask. Okay? Does that make sense? So the ones would indicate, that would indicate what number you're dealing with for the network ID. And this would indicate the host numbers that are available right here, the zeros. If that makes sense.
And a mask is?
A subnet mask is what that's what we call this process. That's the subnet mask. We're establishing a subnet mask. Okay. Does that make sense? Okay. We want to stop and ask for Any
Why do
clarification?
you typically default to 255.255.255.0?
Because you're working
Ha-
on a Class C license.
Yeah. Yep.
Put it simply.
Yep. And this also enables, and I don't want to get too far in the weeds here, and also too far over my head as well, because this can get deep, but one of the things that subnet mask, when you add that to the network ID in the switch, in the router, in this case it would be the router, that will give you you add those two numbers together and you wind up with
And them together.
and you wind up with the true
Yep.
network ID. Yeah. Okay, yes.
So basically what you're saying is on that network, you've got 254 items in the building, you can SI them all an IP address apiece. Then you get any more than that, you can subnet and identify using 255.
Yeah, without the subnet mask, let's say on one side of the router, you might have a particular network ID address, right? And on your side of the router, if you're in your home, you have that same network ID address without the subnet mask. What a subnet mask will allow you to do is take one of those host IDs, one of the host IDs on your side of the network and split that out into what appears to be more network IDs. Okay? So in other words, you're just extending the number of available networks or network IDs on your side of the router. The router understands what's going on when it goes back on the other side, upstream of your network, if that makes sense. It's a way of extending the numbers available.
Now, and again, I'm probably wrong, because I made this leap years ago, but isn't that subnet mask help manage what you're broadcasting to?
Yeah, it does.
Whom you're broadcasting?
Yeah, it does. Because now you can split out.
Basically just broadcasting within
Yeah,
that mask.
exactly.
Not outside.
Typically, you're going to be broadcasting to even a lower number of host IDs than you'd have in a Class C network.
Right.
So when you break that out, you can be broadcasting, to very specific areas of your network, and it makes things much more efficient. Anything you want to add to that, Robert? Okay. Yes.
Is there any way you can give this to us tonight, today, rather than put it on the flash drive for Saturday?
Yeah, I don't see any reason why. Sure.
Send it out to us? 'Cause
Sure.
I'd like to study this a little bit more.
Absolutely.
It'll be up on the Google Drive here.
Already first. Yes.
Okay.
Can you tell where it is? It's on Google Drive. You gotta have
I
it.
gotta look at
As
this
long as
again.
Brian hasn't made
It's
any
too fast,
modifications
right?
in the last 2 hours.
It's final form, yep. Oh wait, you got the older version. I added a couple things, a couple links at the end. So let me just give you my flash drive when I'm done, and then they'll have the links to the videos too.
Next break.
Okay. What time? Oh, we're sailing through this. It's 20 minutes.
But don't give me
Wow.
a test tomorrow morning.
Oh no, we're assessing we're checking for understanding here,
Don't worry,
buddy.
Bruce, no test tomorrow morning.
Short
Tonight
answer.
before dinner.
Is that your ticket? You can go eat more lunch then.
Oh, I just shut my
Better
mouth
hurry up,
next time.
it's 4,000.
Brownies even?
I hear that.
I think we've already talked about DHCP and DNS. It's just basic awareness there. Okay, so let's talk about Ethernet for a minute, because we all hear about the term Ethernet, and even that term has changed since I've been in the field. Ethernet used to be very specific to just basically to cabling. Now it governs a whole bunch more. When you say Ethernet, it governs a whole bunch more stuff, connotes a whole bunch more stuff than when I was starting in the field. But basically now, Ethernet is a standardized method for connecting computers to a network. Think of Ethernet as a building code for networks, defining the cabling, what media might be appropriate, what type of connectors you're going to use, how long you can run those runs, et cetera, okay?
So, I always get the question of, well, how is Ethernet different from TCP/IP?
Well,
Harder
yeah,
versus
it's-
different set of rules?
yeah, I mean, think of both honestly as rules, but Ethernet's more expansive because it helps define the media and the transmission rate, all of that stuff. Yeah.
The easiest way to explain this is Ethernet is the hardware, TCP/IP is the language you talk on that hardware. Exactly.
So this is layer 1 or 7, I can't
Don't talk about the OS.
So I'll have enough time for that.
In the OSI model, it's layer 2 and 3 of the OSI model, if I'm not mistaken. Oh, that's data.
Model.
If
That's the old model? Okay. See, I can't keep up with this
If I
stuff.
understand what you're saying, all TCP/IP is Ethernet, but not all Ethernet is TCP/IP?
No.
No, can't you say that?
You can't say that either. Ethernet is the hardware specification.
Right.
So it is the
So
physical.
TCP/IP does not have to be over Ethernet.
Correct. Because we use TCP/IP over wireless all the
Right.
time.
Right,
Okay.
right.
That hurt.
So, if you think about it, Ethernet is like the paper we're writing on, okay? Think of it like that.
I'm with you. I'm with you.
TCP/IP is the English that we're writing on that paper. It's the English that we're talking on with the telephone. It's the English we're typing into the computer.
Or the English we're using for sign language.
Absolutely.
But this
Any
is,
other protocol
and-
we're using to translate the.
And think this too, is there's 7 layers of the OSI model.
Oh, no.
At the 7th layer, the lowest, that's where the Ethernet media side comes in and meets up with, and then on the top layer, as you're going up to the, the management software, then you're getting into the definition of the, exactly, the data packets, et cetera, et cetera.
I'm there already. Yeah.
but this is a good example of why we need some really good
Boom.
core
Hit it on the head.
graphics. Because, for students
Yeah.
and others, I mean, a few
Yeah.
instrumental piece of good
Absolutely.
graphics are critical. And, I mean, sometimes everybody doesn't have graphic artists to do all that, and that time, it takes time for instructors.
Right.
But if we could collectively come up with some incredible process graphics that everybody
Yeah.
could share, I think that would be a very
Absolutely.
important thing.
The good news here is there's a ton of stuff
Yeah,
for
well,
this, but
Yeah, but
yeah.
I'm just saying this is a good example when you're
Absolutely.
talking about, two-pipe systems or,
You got it.
whatever it is.
we need to build that out
Like
in
a
our
person
field
sitting
more,
in a
yeah.
chair making graphics for us.
Yep, agreed. Okay, so Ethernet has become far and away, we all know this, the de facto standard for networking. And twisted pair has become, we don't see RG58 cable, coax cable much anymore, BNC connectors from the old days. You don't see that stuff much anymore. It's all going to be Cat5, Cat5e, Cat6 cabling that you see out there. You still do see some ArcNet. ALC still uses ArcNet, I believe. That's a little bit faster than what we would have in, let's say, BACnet MSTP. I think it communicates at 56 kilobits per second or something like that. It's a little bit finicky, but it still is out there. Token ring, the old IBM standard from way back. I remember my dad worked for IBM, so I remember him always talking about the token ring networks. You're not going to see those too much out there anymore. So you're going to run into Ethernet.
We're working in the same building,
Let's say, you're not going to see him in this building. How about that? We could visit your campus and see some of the old stuff. Good, okay. Okay, so just briefly, there are several different topologies. I think we're going to breeze through this. Most of you have seen bus, star, ring topologies, et cetera. It's just the way you lay out your networks. Ethernet, sometimes you'll hear it referred to as the 802.3 standard, okay, from the Electronics and Electrical Engineers International Association, IEEE. They're the ones that set all kinds of standards for Ethernet, from wireless to wired to, you name it. I'd encourage you to go, if you have more interest, go there, and they have a lot of good resources on that site. A lot of my students became IEEE members. I think it's a great thing for your students to get involved in. Also BACnet International with all their free resources, et cetera, et cetera. But it's a good site to direct your students to early on in their program because there are resources there that they can take advantage of. Original versions of Ethernet would move data at 10 megabits per second. Now we're up in the cabling that we're using. Today, the Cat5e cable is gigabit cable, okay? You can also get Cat6 you can get that in 10 gigabit, I believe.
Yeah.
So a
On
lot.
copper. 10 gigabits on copper,
Yeah.
not on
Okay. Let's just run through some of this. Twisted pair, this becomes more specific now to what we'll be dealing with today as we make our own patch cables and as we get into making the connectors and crimping those down and building our own, Ethernet Cat 5e network, which we're going to use to share information on the controller. So, comes in various grades or categories, as we've already discussed. Their categories are set by ANSI and EIA standard 568. EIA and TIA are the Network Plus folks, and I also encourage your students to pursue that because of the lack of certifications in our field. One thing that we really encouraged our students to do, and we know it was a differentiator when they went for jobs, is to get that Network Plus certification. Okay, we went through about half the book. Let them go through the rest of the book and then sit for it, but we really encouraged them, and we saw the benefit of that. Employers really like to see in our field Network Plus certified.
Expensive.
No, it's not. It's not. No. Good.
It is distinctly possible that your college offers some sort of network certification. It could be the Network Plus certification. It could also be one of numerous Cisco certifications. It's kind of the generic certification versus the name brand. It covers basically all the same material. It's just the Cisco certifications are oriented so that it also includes a hardware aspect of, imagine that, Cisco. So, they are, if that's what your college has, and you can work with your IT department to or your academic side IT department to get your students into that so you don't necessarily have to reinvent the wheel with it, that'd be great. Sometimes IT departments are a little bit sticky on the prerequisite side. Paul?
Yeah, I'm not sure what the situation is with different colleges, but in our college, there is quite a great variety of programs. We have a computer information systems program. Part of my curriculum for my building automation program, one of the courses that they're supposed to take is networking essentials. I didn't write a program. I have them take it with
Yeah.
the computer department.
Yeah.
Exactly.
It's a way of integrating.
Yeah, we tried to do the same thing. Some are more open to that than others. The problem we ran into is that they would require a lot of prereqs to take the class that we wanted. That would feel a problem.
One of the things I did was I went to work with our engineering department, who also needs to do networking for industrial networking. So my students take an industrial networking class first, and then my networking class is strictly backnet and
Yeah,
a little LAN.
okay, yeah. I remember that class, because I looked at it.
It would have been crazy trying to advise that class.
Anything else on that? Okay. The cable we'll be using today is Cat 5e. You should be putting in, and anywhere you should be using Cat 5e cable now. If you really want, if you really want that, Cat 6 is going to be about twice as expensive per linear foot. But if you really need that speed, then put in Cat 6. But certainly everything that goes in now should be Cat 5e.
What, plain
Not in
5?
that case anymore, Brian.
It's not? Cat 6 has come down?
Is
Comparable in price.
comparable in price.
Okay.
It's a little bit more money.
Starting to border on cheaper in some places.
Is that
just
right?
because of the-
Wow. So that's
Now,
just changed in the
that's
last,
Cat 6, not Cat 6A. Cat 6A is the one that they're pushing the 10 gigabits on, and you don't want to try and work with that in the first place, so just go with the regular Cat 6 cable.
the regular is 1 gigabit, just like the 5e. So what's the advantage of the Cat 6 over the 5e
Less
then?
signal attenuation on long runs.
Okay, but still 100-meter limited as far
Yep.
as distance? And with the 6A as well, 100-meter limit?
6A can go a little bit further.
Okay, okay. Okay, there you go, fast-changing industry.
Still got copper. For our purposes. I mean, there's no real difference in making the ends, is there?
The
No,
ends are
the-
different.
no,
If you go
yeah,
with the
just-
bigger cable,
Are they a little different? Okay,
you can buy ends that'll do both, but regular 5E ends won't work on some 6 and 6A cables.
okay. all
Yeah,
right.
they will, you just gotta put it where you plug
We'll put it this way, they're not rated for it.
That's true.
Yeah, right.
That is true.
Listen, half of my ends
You
get
don't know exactly.
screwed
what
up,
is in-
thrown out anyway.
Yeah.
I hate to go buy it all new ends.
That's
Yeah.
why
Don't
you
buy
get
the
these-
expensive ones if
Yeah.
you're practicing, there you go.
Yeah,
I'm just
Yep.
saying, like.
More
you
practice
buy
for your students.
You buy good students, their cables are, like the ones you buy out of the store.
yeah, yeah.
Just a matter of practice.
Yeah, they're not efficient at it yet. I just teach them how to do it, not how to do it well.
Okay, so what we'll be using is unshielded twisted pair, which is the most common out there. You also have shielded. Typically, the shielded is going to come with foil. You can get it heavily braided with copper. If you have it really, it's going to be expensive. If you have a really high interference type situation, you're running it by a lot of ballasts or motors or something with you know, a lot of magnetic fields, or yeah, exactly. You're going to want that extra braiding on the copper, and that's going to be quite a bit more expensive when you get into those options. But we'll be dealing with UTP cable, unshielded, twisted pair, and that's what you're going to run into predominantly out there in the field. In here, you can look at this later. It gives you some of the tenets of each one, of Cat 5e, 6, 7, et cetera, et cetera. They pretty much all run about 100 meters. You can run them about 100 meters. Probably want to stay a little bit under that, but you can run them up to 100 meters. I don't know if you've had experience with 6A. You said it's a little bit, you can make the runs a little bit longer.
I remember right, it's a little bit
Okay,
longer, but
okay.
not appreciably so. And the cost is significantly
Is it really? Double, triple per linear foot, you think? Or?
on the scale of double, I think.
Okay. Okay, twisted pair cables are going to have 4 pairs. Okay, so you've all probably seen this. When you open up that sheath, that PVC sheath or the plenarated sheath or whatever, you're going to see 4 that are twisted together. And they're twisted because of, well, you want to cancel out any kind of noise. That's a big issue on the conductors. And if you twist them, it's going to take, instead of a lot of parallel runs where you could get more crosstalk, more induction in those cables, they twist the cables, and that's the reason for the twisting. You only use 4 of the 8 conductors for communication. So why would you have the other 4 in the cable? Anybody have an idea? Data? Spare?
Maybe we can send the power with it.
Daisy
Yeah.
chain?
You actually can run, if you go back to 10100, you can run in one of the cables, you can run 2 runs, split them. For 100 fast Ethernet, I believe it needs only 4 cables. For over a megabyte, no, for a gigabyte or more, you'll need all 8 of the cables.
Oh, to uprate the speed. I was always told to stay away from running anything on those other 2 lines because of crosstalk, interference, potential
Actually,
issues.
for-
But
So, it was an old IT trick that if you didn't have enough ports in a space, they made splitters that you plugged in on either end, and you could you could use one line to communicate on 2 ports. It wasn't, particularly advisable, but it only worked at lower speeds. So once you got into high-speed applications like gigabit, it doesn't work.
You need all 8 of the cables for the gigabit.
Nope,
And
you still only use 4 for gigabit?
that was my understanding as well, that you only use the 4 for gigabit and 10 gigabit. But, I mean, that's something worth looking into. Maybe
I don't
maybe-
know. I would think not differently.
But I did hear the right answer, or a correct answer for one of the things that we used the other 4 for, which was
PoE.
PoE.
Yeah, power over Ethernet. Yep.
Very common, especially with security cameras. Telephones now, the ones on the desk you see around here.
Mhm.
And we are starting to see it in our industry as well, because we're starting to get controllers that are PoE.
You want
It's
to,
a really
Yeah.
cool thing.
do you want to explain the advantage of PoE? Why we use it?
Well, we went to it because when we used to have telephone data switches before, all the new telephones, when they started going to Ethernet type of data connection, you always had to have a wall wart or something else plugging in. So many industries now use that. A lot of newer lighting controllers that I've been messing with, and when you're using a data cable anyway, and I'm a union electrician, not to get rid of the electrician, but when you're using one cable, why have to run power too? For these devices that have been more and more efficient, like lighting uses a lot less wattage, and the PoE standard has gone from 15 watts up to 30 watts and upwards towards 50 and 60 watts on each Ethernet port now. We can get a lot of illumination from LEDs. So to run one wire and have the power and the data in one cable, I think that's
Yeah.
some of the advantages that we realize from power over Ethernet.
Yeah, thanks.
You think
That
some of them
explains
run
it.
Yeah, thanks.
with 60 watts through there, and what voltage?
Some of the newer standards are coming out even higher than 60 watts in one.
What voltage is it?
The voltage is approximately, I think, 48 to 52 volts, something like that. Most of the common PoE standard, or the real PoE standard, some people are using different voltages, but I think it's around 48 volts. It's DC voltage.
Straight filter.
Comes out of the PoE switch.
Which
So
is-
you power the switch, you plug it in, and whatever's on the other end, you don't have to need
Yeah.
any power for it.
Yeah,
That's
you
why
got,
you
gotta
see
be,
now
gotta be
these
DC
lights
so you don't get any
with
interference, otherwise you'd just be
dropping
shot for your
cables waving around.
communication, so.
So it burns the
Good.
building down.
Okay, thank you for that, Bill. There you go. There's a picture. So, yep, you've seen that before? Yes.
That's what it looks like when you get your jacket off.
We saw it quite a bit down at your place, didn't we? Okay. Okay, so now getting into Ethernet RJ45 connectors. You're going to be putting these together this afternoon and very shortly. Making a patch cable requires knowing the pinout configuration you're using. Okay, there are two standards set by EIA, 568A, 568B. Most of the installed base out there is 568B. We're going to be doing 568B. A standard cable uses the same standard on either end. It doesn't matter if you use 568A or 568B. It doesn't matter, as long as you have the same pinout configuration on both ends. That's a straight-through cable. A crossover cable, which you would use to, if you wanted to communicate between, let's say, these two computers directly, you would flip the receive and transmit cables, and you'd have what you call a crossover cable. So one side would be 568A, one side would be 568B. Okay, we're not going to do that today. But-
And there's a very specific reason we're not going to do that. It's a unicorn. You almost don't need the unicorn.
Yeah.
Because the network cards that we're putting into our computers are smart enough to know that, oh, it's just another computer on the other end. Okay, we'll just swap it ourselves. So you will run into people who have been in the field, especially in the controls field or the networking field for a long time, who say, you gotta teach them how to use crossover cables. And the computers are smart enough now that unless you are doing it for some other reason, you don't need to teach them how to do crossover cables.
And the routers.
You don't have uplink on your router or switch when you use a crossover cable.
You should still get link light either way. This transition started, I think they started doing it, the major manufacturers started doing it like 2005, 2004, something like that, where they were starting to put out the cards that were smart enough to install all the config. It's hard to remember if the old ones didn't, or did show link light or not.
I thought they just did it, so you had to untwist two of the pair, cross them over and try to get them to plug. You made it as hard as possible. I always thought that's the only reason they did
Of course,
that.
that's what I did. Barrier to entry as a BAS technician. If you don't know this, you don't get a job, right? Okay, so again, this is all there for you, but you can find this information anywhere. Yeah. Okay. Again, you're just using pins 1, 2, 3, and 6 in these connectors. The others are spare, and they don't recommend you putting anything else on those. But for either one, whether it's 568A or 568B. Okay. Some tips: always cut a little bit more when you're making the cables than what you think you're going to need. I can't tell you how many times I've come up a little bit short on those cables. Avoid, we talked about the interference, avoid sources of interference, obviously. Don't exceed 100-meter runs. Label on both ends before you run through a wall or run to somewhere where it's like, dang. And then you got to get that cable tester out 100 times or whatever. Label them on both ends. That's the best way to do it when you put them together. So, okay, so as part of the workshop, you'll be creating your own straight-through patch cables following the EIA 568 standard. We're going to watch a couple videos, about 15 minutes worth.